In this video, I'm going to explain why any foil product, when put directly under shingles, will not act as a radiant barrier. This includes our roofing foil, all-in-one synthetic underlayment, and radiant barrier. In order for a radiant barrier to work, it must have an airspace. So this is going to be under roofing products like coated metal, coated shingles, standing seam metal roofs, barrel tile, or some other type of roofing system that has battens. Usually it has that airspace. There's also some corrugated products that will lay on top of the roof deck that are mechanically attached without battens that have minimal contact that a radiant barrier will work. But anytime it goes directly under a shingle without an airspace, any foil product, it will not act as a radiant barrier. And in this video, I'm going to demonstrate and explain exactly why. Don't be fooled. You'll see that some products say they're either approved by an insurance company or some other type of organization to be used directly under a shingle roof. And technically that's true, but remember, in every single case, that approval is as an underlayment, not as a radiant barrier. Roofing foil is approved to be used as an underlayment. However, you can't put it directly under the shingles. Trust me, nobody wishes this were not true more than me. We would sell a lot more products if you could simply scrape off shingles, put down roofing foil, put down new shingles again, and make your home more comfortable and energy efficient. But it doesn't work that way. You may have even seen some other products claim to help save energy if you put the foil directly under the shingles. I've seen them too, and trust me, this is just marketing fluff. What you will never see is a third-party, independent testing lab who has an engineer who will sign off on that report to back these claims. It just doesn't happen. Understand that you can definitely use a foil-backed product directly under the shingles, and it'll work fine as an underlayment, but don't expect the attic temperature to be any cooler or expect any energy efficiency from installing the foil this way. First, I'm going to show you the concept of the required airspace, and then I'm going to use thermal imaging to show you exactly how it works, or in this case actually how it doesn't work. Remember, radiant heat is the heat transfer from one object to another object without contact. For example, if this brick was really hot and I put my hand a couple inches away, I would feel the heat coming off the brick and it would warm up my hand without the two ever touching. This is radiant heat transfer. If I actually put my hand directly on the brick and eliminate the airspace, then my hand will heat up by conduction. This is conductive heat. Now, if I put a piece of aluminum foil between the hot brick and my hand, I really won't feel any of the radiant heat because the aluminum surface is reflecting 97% of the radiant heat. Here are where things change. If I move the aluminum foil and my hand directly in contact with the brick and eliminate that airspace, now the heat will go right through by conduction. There are some products out there that combine foil with either some bubble material or some foam. And the concept is exactly the same if you put a product like this directly under the shingles or against the brick. Once again, if you put it directly against the hot surface without an airspace and eliminate that airspace, the heat's going to go by conduction through the material. Now, the foam itself will slow down some of the heat. That's because it has a small amount of insulation and it's acting as an insulator. But the foil itself is doing nothing. For an application like this, you'd be just as good using a foam product without the foil. Okay, let me set up this experiment for you to show that putting foil directly under shingles will have no benefit without the airspace. I've got 5 different sample areas. First, I've got the roofing foil with the foil side up, roofing foil, foil side down. This is basically the roofing foil without the foil. It's just the underlayment part. Black tar paper, standard underlayment, and then a synthetic plastic roofing underlayment. What we're going to do is we're going to take the shingle material and put it on top of these samples. Then we're going to heat up bricks and put a hot brick on each one of these areas. Let it sit for about 10 minutes. Then we're going to come back, lift up the bricks, lift up the underlayment and the shingles, and use thermal imaging to see the temperature of the deck below. What you're going to see is virtually all of them are the same, almost no difference in heat transfer between them. And this proves that you must have an airspace in order for foil to work in a roofing system, and that if you put foil directly under shingles, it has no additional benefit. There is one application where putting the foil directly under the shingles would be beneficial, and that's in fire resistance. The additional layer of aluminum between the roof deck and the shingles would provide more fire resistance through the overall roofing assembly. But once again, no benefit as far as energy efficiency. Okay, let's get started. I've got my hot bricks, and I'm going to put one on each sample. And we're going to let this sit for about 10 minutes, and then we'll come back and see what happens. Okay, the hot bricks have been sitting on the shingles and the underlayment for about 10 minutes. So we're going to take all these off. We'll take the shingle material off and then remove all the underlayment samples. Now, what you should be able to see is that virtually all the thermal imaging, the spots are exactly the same. Pretty much whether it was foil side up, foil side down, the synthetic underlayment, the tar paper, all basically the same as far as heat flow through the shingles and into the roof. And what this proves is that you must have that airspace for foil radiant barrier to work, and that you cannot put foil directly under shingles. It makes no difference. So I hope you enjoyed this video on why a radiant barrier must have an airspace. So in conclusion, remember this: no airspace equals no radiant heat equals no radiant barrier. You cannot have a radiant barrier without that airspace. If you have any questions or comments, visit the website roofingfoil.com or give us a call. We'll be glad to help you with your questions or technical applications.